So 1.7 number 4 is asking us to, well, the first part is asking us to eliminate the parameter to find the Cartesian equation given the set of parametric equations. X is equal to sine 1/2 theta and y is equal to cosine 1/2 theta on the interval from negative pi to positive pi. So this is a pretty basic one that you'll see often. You have sine and cosine and they have the same argument, same factor. It's pretty easy to eliminate the parameter because we just use that relationship of the unit circle, the x squared plus y squared is equal to 1. So in our case, x squared plus y squared equals sine squared 1/2 theta plus cosine squared 1/2 theta equals 1. So that eliminates the parameter for us completely. Or x squared plus y squared is equal to 1. So part B is asking us to sketch the curve and then indicate with an arrow which direction the curve is being traced. So we're going to look at points x, y, but what we're going to think about is these points in terms of our parametric equation. So x is represented by sine of 1/2 theta, and then y is represented by cosine of 1/2 theta. And the values that we're going to use for theta are indicated by this given interval. So the leftmost value, the smallest value we're going to use is negative pi, and the largest is pi. So you only need a few values in between to understand what's going on. So let's start with the leftmost value, or the smallest one, negative pi. So our first point, if we substituted a negative pi in, would give us the sine of negative pi over 2, and then the cosine of negative pi over 2. So to figure out that point, we have to recall our unit circle, and recall that negative pi over 2, the angle is down here, and this is represented by the point 0, -1. So remember, the x coordinate represents sine and the y coordinate represents cosine. So the sine of negative pi over 2 would be a -1. And then the cosine of negative pi over 2 would be 0. So if we were actually graphing this, we have a -1, 1, and a +1. We only need half a circle because this 1/2 tells us that we're only going to rotate half of the circle from negative pi to pi. So that would be this point here. So if we pick another value on this interval, I would use 0 because that's a nice easy value to work with. So the sine of 1/2 times 0 would be 0, and then cosine of 0. Well, 0 is here, this point, so that point is represented by 1, 0. So the sine of 0 is 0. And the cosine of 0 is 1. So that puts another point here. So our curve is looking like this. You see the direction we're moving in here. To finish it off, we could just use pi. So the sine of pi over 2 and the cosine of pi over 2. Remember, we're just substituting in for theta. So pi over 2 is here, and that's represented by the point 0, 1. So sine represents this y coordinate here, so this would be 1, 0. So that's this point here. So we have this half circle moving in this direction from left to right. Part A says we want to eliminate the parameter to find the Cartesian equation for the curve. So we can solve for e to the t in this first equation. So x equals e to the t minus 8. So if we add 8 to both sides, we get that e to the t equals x plus 8. From here, we can take this and substitute it in for y. So y is equal to e to the 2t. But if you remember your rules of exponents, another way to look at this is e to the t raised to the second power. So we can take this x plus 8 and put it in right here. So that's going to give us y equals x plus 8 squared. And then we have to figure out the restrictions on x. So if we think about this e to the t here, this is what's going to help us find the restriction. E to the t equals x plus 8. This e to the t is never going to be negative. It can be 0, but it can never be negative. You can punch this in your calculator. E is always a positive. Because of this, we have restrictions on x. So we have to think about when is x less than 0. I'm sorry, x plus 8 less than 0. We want to kick out all those x values. So we want to keep everything where x plus 8 is greater than 0. So we can add the 8 over, and that tells us that x is greater than negative 8. B asks us to sketch the graph and indicate with an arrow the direction the curve is traced. The easiest way to do this is kind of make a table. You use some t values, and then you have your x and your y. X is equal to e to the t minus 8, and y is equal to e to the 2t. So I just use a few small values to get an idea of the direction of this curve. So this would be e to the 0 minus 8, or 1 minus 8, which is negative 7. This would be e to the 0, which is 1. So you have a point, negative 7 and 1. Do the same thing. Substitute the 1 in, you do e to the 1 minus 8. That gets you decimal negative 5.28. Then you have e to the 2 times 1 is 2, so e to the 2 is 7.39 approximately. So you have another point, negative 5.28 and 7.39. And e to the 2 minus 8 gives us negative 0.61. And e to the 2 times 2 is 4, so that gives us 54.6 approximately. So we have a point, negative 0.61 and 54.6. So this gives you a general idea. It's just ask you to sketch the graph, so it doesn't have to be perfect. So negative 7 and positive 1. It's right here roughly. And then we have negative 5.28, so 1, 2, 3, 4, 5, and some change, and then we go up about 7. You can see that it starts to go in this direction here. So if you were to include it with the arrow, it looks something like that. So the first part says we want to work on eliminating parameter to find the Cartesian equation. So we need to solve for t in terms of x and then substitute t in the equation for y. So they told us that x is equal to the natural log of t. So we need to solve for t. The inverse of a natural log is the e function. So to eliminate this natural log, what we have to do is we have to do e to the power of each side of this equation. So e to the x is equal to e to the natural log of t. You should have learned this in pre-calculus. So the e and the natural log cancel out, and that leaves us with t equals e to the x. So part 2 says we can now substitute t in for y to the Cartesian equation. So because y is equal to the square root of t, we can simply substitute this e to the x in for t. So e to the x. Another way to look at this is e to the x raised to the 1/2 power, or possibly e to the x over 2. All of these are exactly the same thing. Finally, part 3 says we are also given that t is greater than or equal to 16. To find how this restricts x, remember that x is equal to the natural log of t, and that a logarithmic function is increasing. Therefore, if t is greater than or equal to 16, x is restricted as follows, and that's what they want us to figure out. So if we know that t is greater than or equal to 16, and we also know that x is equal to the natural log of t, that tells us that x must be greater than or equal to the natural log of 16. And this is approximately 2.77 rounded to 2 decimal places. That's from the calculator.